Students, today we are going to discuss the topic binary operations. In the previous classes, you may have learnt about the number system, that is starting from the basic number system, that is natural numbers, then integers, then rational numbers, irrational numbers, real numbers. So like this, we have discussed many number systems, right? Now I will take one instance. When we take natural numbers, suppose I consider two natural numbers, that is in the set of natural numbers. As an example, 2 and 3 if I take. You apply the basic operation, that is addition. When you perform the operation addition on these two natural numbers, that is 2 and 3 as an example if I take, that is 2 plus 3 if I take, what we are going to get? 2 plus 3 is equal to 5. So if I write like this, 2 plus 3, that's equal to 5. So what we are going to get is again a natural number. So what we have done here is, for the two natural numbers 2 and 3, we have applied the operation addition, and as a result we are going to get again a natural number. So what we are going to get the result, that is again in the same system. It doesn't go into another system like some other negative number and all that we don't get. So therefore addition we call it as a binary operation. This is one of the basic example. Similarly, if you take suppose the real numbers, suppose I take a 2 and minus 3. So 2 minus 3 if I do, then it becomes 2 minus 3 it becomes, then that is equal to what we are going to get, minus 1. So 2 and minus 3, if I add, I am going to get minus 1, and it is again a real number we are going to get. So if I take the operation addition or even subtraction also if I consider, then what happens is these operations, after applying, what we are going to get, it is in the same system. So therefore there is a need to generalize this concept. So therefore we are going to generalize this, and therefore we discuss the topic binary operations. So what binary operations in general mean? So you take in general any operation, generally addition, subtraction, then multiplication, division. These are the symbolic representation of these operations we are going to take, correct? So therefore now what we are going to do is, so collectively so many operations are there. So generally we represent it by the notation star. That star can be plus, it can be minus, it can be into, anything we can consider under the system. So you take a operation, star you denote it by star, and it is called a binary operation. When we call that operation star as a binary operation, if that star is a function from the set A cross A2 itself, that means, as an example I will illustrate you here, you just see. Now in place of star I will take addition. Addition I am going to consider now. So addition is the operation, I am going to consider on the set of natural numbers. To perform addition, how many elements are required? 2 are required. So therefore we take the set n cross n. 2 elements are required. So as an example, so n cross n, if I take 2 elements, 2, 3, these both are natural numbers, right? So 2 and 3 both are natural numbers. Now if I perform the operation addition on 2 and 3, I am going to get 5. This 5 again belongs to natural numbers. So therefore n cross n2, it is mapping to n only. So therefore what we can consider is addition is a binary operation. Addition is an operation, and it is not only operation but also it is a binary operation on the set of natural numbers. When we perform that operation on the elements of any elements of the natural number system, you are again going to get same natural number. Therefore it is a binary operation. So now therefore in general, if you take any set A and if you are going to take a operation star, then it is called as a binary operation if it is a function what happens in a function? In a function, for every pair of elements, there exists a unique element in the codomain. That should happen, right? So therefore, here also same condition should be satisfied. So the definition is simple. Generally in exam, they have asked a question definitely in this topic, and this even the basic definition also has been asked. So therefore, the definition is simple. A binary operation star on a set A is a function star. It is a function star from where? A cross A to the set A itself. This is not going to change. It is going to be the same set A. You are going to get the element. So therefore, it is a binary operation. So like this, many examples it is possible to give. Now multiplication. If I come to multiplication, just see here. Instead of addition, I will take the operation multiplication. Now multiplication, again on the set of natural numbers, that operation is a binary operation. You randomly take any two natural numbers. Suppose I take 5 and 7. So if you take apply the operation into, so 5 into 7, what is the answer? We get 35. Is it again a natural number? Yes, it is a natural number. Therefore, multiplication on the set of natural numbers is again a binary operation. Now I will give one more example where you are taking an operation, but it is not a binary operation. Such an example we will see. Again in natural numbers only we will take. Suppose I take subtraction. Subtraction is a basic operation, right? So in subtraction, if I take from n cross n to n, if I take, this is not a binary operation. This is not a binary operation. Why it is so? I can give an example where this is not going to be satisfied. So if I take 2 and 3, same example I take 2 and 3, both are natural numbers. Now perform the operation 2 minus 3. Minus is the operation I am going to perform. So 2 minus 3. So 2 minus 3, that is equal to minus 1. This is not a natural number. It becomes an integer. Correct or not? So therefore, if I apply subtraction on the elements 2 and 3, the answer what I am going to get is not a natural number. It is an integer. So therefore, subtraction is just an operation, but it is not a binary operation. So this is one or two examples in case of natural numbers. Now coming to real number system. What about real number system? So if I take real number system, in real numbers, if I take addition from r cross r to r, this is definitely a binary operation, because sum of two real numbers is always a real number. Therefore, it is binary. Similarly, if I take multiplication from r cross r to r is again a binary operation. As like in the previous case, here also what happens is product of two real numbers is definitely a real number. You are not going to get a number which is not real. Therefore, definitely it is a binary operation. Coming to the subtraction, definitely subtraction of one real number to another real number is again a real number. Therefore, it is binary operation. But when we come to division, the operation division on the set of all real numbers, division on the set of all real numbers is not a binary operation, because one case gives the problem, that is if I take 0, so 1 and 0 are considered, both are real numbers, right? 1 and 0 are both are real numbers, but 1 divided by 0 is not defined. It is not going to be considered as a real number. So therefore, division is not going to be considered as a binary operation. So now I will take two basic two more examples I will take. So question number 1. show that subtraction and division are not binary operations on n. Now, if I take subtraction, so as I told earlier, subtraction from n cross n to n, this is not a binary operation. Is not a binary operation. Is not a binary operation. Why it is so? For example, I'll take one example. So similar simple example I'll take. 2 and 3 belong to n, but 2 minus 3, I apply the operation minus, that's equal to minus 1, does not belong to n. That is enough to say that it is not a binary operation. One more example if I take, show that star from r cross r to r given by a star b equal to a plus 4b square is a binary operation. Why it is a binary operation? Now consider r cross r, you have to take a and b both from real numbers only. So you take any two real numbers. If you take any two real numbers, see first you see here b square, if I consider square of any real number is a real number, then multiplied by 4. 4 times that b square is definitely a real number. To that, add a to that. Then what you are going to get is definitely one more time it is a real number. So on the whole, a plus 4b square is definitely a real number. It is not going to be some other number. So therefore, definitely this belongs to the same system of numbers. Therefore, a star b given by this is definitely a real number. So how to write the answer? So in examination they ask question of this kind, whether it is a binary operation or not. How we decide that? So the solution can be written like this. I'll just write the solution here. The solution can be written as, see, for every we have to go to the basic definition. What the basic definition says: an operation is binary if it is a function from where? From a cross a to a. That's the general definition. So in the similar pattern we have to write now. So if I take for every, not one or two case, in fact for every case I have to consider, for every a comma b that is a real number, for every a comma b belongs to R, that exists a star is the operation. Here what is the star operation? That is denoted like this: a plus 4 times b square. A star b, that is going to be a plus 4 times b square. A plus 4 times b square. This also is a real number and it is unique, remember. So for every a comma b belongs to R, there exists here one important word we have to write. After that you have to mention this, that is, there exists a unique, that is very important. There exists a unique a star b that's equal to a plus 4b square. This again is a real number. Therefore, it is a binary operation. In a function definition, we have seen that. What is the definition of a function? It says that for every element in the domain, there exists a unique element in the codomain. So it is the same thing we are going to say here. So for every a comma b belongs to R, there exists a unique a star b which is given by a plus 4b square, that is again a real number. Therefore, star is a binary operation. Star is a binary operation. Now students, we will take one more example, that is, see here, determine whether or not each operation star given below are binary or not, we have to check now. So here, earlier we have taken examples on natural numbers and real numbers, some binary operations we have discussed. Now, I will take integers. In that too, a subset of integers, that is a set of positive integers if I take, then see here, on set of all positive integers is a plus. We will define a star b as a into b, that is product of the numbers A and B. So our star binary operation is, what is the binary operation? That is nothing but product of the two positive integers. That is the binary, that is the operation we are taking. Whether it is binary, definitely it is a binary operation, because we know that if you take two positive integers, when we multiply, what happens? You are going to get a positive integer again. That's why it is binary. So how to write the answer? In examinations they may ask a question of that kind. Then how we write? So for every a comma b, that is a positive integer that belongs to z plus, there exists a unique a star b that's equal to ab, which is again belonging to z plus. This is the way we have to write the answer, because earlier in definition we have seen, in the binary operation, what is the definition? It should be a function, we say. In a function, how definition comes? In a function, for every element in the domain, there exists a unique element in the codomain. Then only that becomes a function. Therefore, same way we have to give the answer. Then, coming to the second case, on z plus again, set of positive integers, define a star b is equal to modulus of a minus b. What is the binary operation? What is the operation rather we are using here? That is, first subtract a and b, then take modulus. That is the operation we are considering. Is it binary? Now here one thing comes into picture. Z plus. Z plus, usually we consider it as a set of positive integers. Now suppose we take it as only set of positive integers, then there will be a problem. If we take z plus including 0, sometimes we consider z plus is also considered as set of non-negative integers, like that we consider. Suppose I consider it as set of non-negative integers, that means including 0 up to all positive integers if I consider, then this operation becomes a binary operation, otherwise it is not. Now I'll take it as z plus as set of all positive integers including 0, then how it becomes? Then if I take different cases, like suppose a value I will take it as a 2, then b value I will take it as 3, then 2 minus 3 is minus 1, its modulus is plus 1, it is in z plus. Suppose a and b both I take it as a 2, then what happens here? 2 minus 2, that is going to be equal to 0 comes. So if I include that 0 in this z plus, then it becomes a binary operation. Then I can write the answer like this. For every a comma b belongs to z plus, there exists a unique a star b is equal to mod of a minus b, that again that belongs to z plus I can say. Suppose 0 I do not consider in z plus, then this problem comes. Mod of 2 minus 2 is equal to 0, then that doesn't belong to that, then it doesn't become a binary operation. So this is one interesting case where two ways you can have the answer. So it depends z plus whether we take it as set of only positive integers or including 0. So I give a clarity here. If I treat z plus as set of all integers including 0, then it is a binary operation. Otherwise, it doesn't become a binary operation because of this particular example. Like this, we can take 2 minus 2, 3 minus 3, 4 minus 4. Always the modulus will be equal to 0. So therefore, in such a case, if 0 is not considered here in this z plus, then it doesn't become a binary operation. So therefore, many a times in, suppose in examination, z plus they clearly mention whether it is only positive integers or it is including 0 or not, clearly they mention. So depending on that, we have to give the answer. Now, for any operation, we have seen in our earlier classes that, for example, addition. In addition, suppose we consider real numbers, there are many properties satisfied by that operation addition, like commutative property, associative property, distributive property. Many things we have learned in our earlier classes, right? Now, So in general, for any operation which is binary, which we denote by star, let us see some of the general properties. First of all, I would like to talk about commutative property. Coming to the commutative property, now consider a binary operation. Consider binary operation star. On any set A, if you consider, on a set A, it is called as commutative if A star B and B star A both are one and the same. If that happens, then we say that star is commutative on that set A. Now, for every case it should happen. One example I will take. Coming to the real number system, if we take the operation addition, already we have seen that addition is a binary operation. Similarly, multiplication is also a binary operation. So when we take these two binary operations on set of all real numbers, definitely they are commutative. So let us see how it is. It is commutative because for each and every case, for all A comma B belongs to R, A plus B and B plus C are always one and the same. Therefore, addition is commutative. Now, multiplication, if we take A into B and B into A, both are one and the same. Therefore, AB equal to BA. Hence, multiplication in real numbers is commutative operation. Now, coming to subtraction. Definitely, subtraction is also a binary operation in set of all real numbers. And also we have seen that division is not a binary operation, because if I take 0, then division becomes when 0 comes in denominator, that is not going to be a real number. That is the only reason why division is not a binary operation. So what we will do is, from that real number system, I will exclude 0 and I will denote it by R star. So R star, suppose it denotes set of all real numbers except 0, then definitely that becomes a binary operations. So on set of all real numbers except 0, division also becomes a binary operation. If I consider these two cases, that is subtraction on set of all real numbers and division on set of all real numbers except 0, in these two cases, commutative property does not hold good. Why? I will give example. As I told earlier, when it is not commutative, we just give example. We need not generalize. So, just I will give example here. See, we will take simple real numbers like 1 and 2. 1 and 2 are real numbers. And then if I take 1 star 2, 1 star 2 is nothing but if I take the operation subtraction, what is star? Star is given by minus sign now. So minus, if I take 1 minus 2, that is 1 star 2 becomes 1 minus 2, its value is minus 1. And if I take it the other way, A star B over, now B star A I have to take, that is a 2 star 1, interchange these two elements now. 2 star 1, that is 2 minus 1. 2 minus 1 is equal to plus 1. So here I got minus 1. Next time I got plus 1. They are not one and the same. So therefore 1 star 2 is not equal to 2 star 1. Therefore subtraction is not a commutative. That is in subtraction, commutative property does not hold good. Coming to division, in set of all real numbers except 0. Now take same numbers 1 and 2. 1 divided by 2 is half, and 2 divided by 1, its value is equal to 2 comes. So here I got half, and if I interchange the role of 1 and 2, then what I get? I am going to get the answer 2. So therefore 1 divided by 2 is definitely not equal to 2 divided by 1. Hence commutative property does not hold good in division. Now, like commutative property, one more property is associative property. So let us see some examples where associative property holds good or not in different cases of binary operations. So in the beginning we are going to take the basic cases. So first of all we will see what is meant by associative property. Associative property, its definition goes like this. You take a binary operation star. from where A cross A to A, consider a binary operation. It is said to be associative if you take the operation A star B first, then perform with another element C, that is A star B star C. If that is exactly the same as A star B star C for each and every case element, that is case in the sense each and every element in that set A, if this is holding good, it is called as associative property. Now coming to the examples, with the basic example if we go, so again consider real number system. In a real numbers we know that already addition and multiplication are binary operations. So these two are going to be the case where associative property holds good. So why it is so? So already we learned that in real numbers addition, it holds good. See here, A plus B, perform that first, then add it to C. That is exactly the same as A plus B plus C. So both yield the same answer. So therefore it holds good. Associative property holds good. Similarly, coming to multiplication, the product A into B multiplied to C, that is exactly the same as first multiply B and C, after that multiply to A, then what you are going to get, both are going to be one and the same. So in these cases associativity holds good. But coming to subtraction and division, so if I take these two operations, subtraction and division, definitely associative property does not hold good. So on subtraction on set of real numbers, and division of course as I mentioned earlier on the set R star, because 0 if we input, it doesn't become a binary operation at all. Therefore we exclude 0 for the case of division operation. In such a scenario, how it holds good, why it is not associative, just one example I have taken, see here. So for the case of subtraction, I take 1 star 2 star 3 if I take, then what is our star? Star is nothing but subtraction is the operation. So 1 minus 2, 1 minus 2 is minus 1. Again operate with the 3, that is minus 3, again subtracting. So we get answer as minus 4. Now on the other hand, if I take here 1 star 2 star C as star is again subtraction is the operation. So 1 minus star we replace it by minus now. So 1 minus 2 minus 3. If I take, that is 1 minus 2 minus 3 is what? Minus 1. Minus of minus is plus 1. So 1 plus 1, that is equal to 2. So what we can see, here the answer comes out to be minus 4, but here the answer comes out to be equal to plus 2. So minus 4 and plus 2, they do not match at all. So therefore definitely associative property does not hold good in case of subtraction. And coming to division, on R star if I take, then 1 star 2 star 3, that is going to be 1 divided by 2, that is half, again divide by 3. So 1 by 2, when you divide by 3 you will get 1/6, that is 1 by 6 is the value. Here if I take 1 star 2 star 3, that is equal to 1 divided by 2 divided by 3. So 2 by 3 we get 1 divided by 2 by 3. That is going to be the answer. So 2 by 3 reciprocal is 3 by 2. So therefore here I got answer 1 by 6. Here I got answer 3 by 2. So they do not match at all. So therefore these two are not one and the same. Therefore commutative property does not hold good in the operation division.